Hello everyone and welcome to another video. So today I wanted to have a quick discussion about this guy. So this is a homemade DIY miniature APRS system. So APRS stands for Automatic Packet Reporting System. Basically what this is it's a GPS which is then hooked into an Arduino, and that Arduino is then hooked up to a radio transmitter that is going to broadcast packets out at a specific frequency, namely 144.39 megahertz, which is the APRS frequency for amateur radio. So anyone that's listening on that frequency should be able to hear the packets that this system is outputting and therefore know the location of this unit because the GPS coordinates are embedded in those packets. So what I wanted to do today was talk a little bit about how we built this, show the circuit diagram, look at some of the software that we loaded onto it, as well as talk about some of the physical hardware and construction. So if that sounds like fun, why don't we jump in and get started. Alright, so the first thing I would recommend doing is actually heading over to SparkFun and looking for this article. It's the HX1 APRS Transmitter Hookup Guide. They have an excellent tutorial talking about how to basically get the radio, which again in this case is this particular radio. It's an HX1 broadcasting at 144.39 megahertz, which again is the APRS frequency for ham radio in North America. A quick note is this radio is, you need to actually be a licensed ham radio operator with a technician class or better in order to legally operate this. For example, the way I bought this radio is I went over here. I'll leave a link to this vendor as well. You can see the radio is about $50, and actually when you place your order you actually have to provide your ham radio call sign so that they can verify that you are actually a licensed amateur radio operator. So again, this is the radio, but it does take a little bit of certification in order to legally operate this. So assuming you've got that, like I do, again, just come to this website. Again, I will also leave a link to this tutorial, and they talk a lot about the required material as well as how to use APRS, what is it, and more importantly how to hook up all of the different pins on the HX1 radio to an antenna, and then they even have this nice circuit diagram showing how to hook everything up. And in fact, maybe what we'll do is let me go to a set of graphics that I've got to talk a little bit more about this particular setup. So in this case, since it's a SparkFun tutorial, I think they want you to use a SparkFun board, but you can use pretty much an Arduino here. That's what I was ending up doing, and everything works out quite nicely. So this is their wiring diagram, and as you can see, it's a pretty simple system, right? Everything is really built around the radio, right? The HX1 right here, and it's just interfacing with the board, and the board is interfacing with a GPS here, as well as two temperature sensors for getting two temperatures, either the internal temperature and the external temperature of your object or what have you. It also has a buzzer that will allow you to hear where this is going and locate it audibly. Lastly, the thing that's probably important is that it's interfacing with an antenna here, so that the idea is that the GPS receiver will be obtaining the position of the board, which will then be understood by the Arduino. The Arduino will also read temperature readings from these two sensors, and then be able to package all of that up into a packet, which you can then send to the radio, and the radio will then broadcast out this APRS packet over the antenna. All right. So again, you can see it's pretty simple. It's not that bad to hook up. I do want to mention we made, me personally, I made a couple of modifications to this specific diagram. So first is that if you go to the tutorial, they are assuming that you're going to use these LM60 temperature sensors, which are fine, but I actually have a whole bunch of these DS18B20 temperature sensors, which I like a little bit better. So I replaced mine with these temperature sensors. I talk a lot about those temperature sensors specifically and how to interface them with an Arduino in this other video on my channel. It's this Arduino where we made an Arduino data logging system which had GPS temperature sensors and the micro SD card for data logging. So if you watch this other video, I will talk extensively about the two DS18B20 sensors that I used for my application, as well as the specific GPS receiver that I am using for this application. So I would recommend watching that video if you really want to know the details of the temperature sensors and the GPS receiver that I'm using for this particular APRS build. While we're talking about the GPS, what I should also mention while we're staring at this diagram is, if you notice, the way that they kind of recommend you hook this up is to have the GPS receiver effectively into the serial port of your Arduino, right here on channel 0. So the problem with this is that the GPS transmit can actually interfere with the Arduino IDE when you are trying to upload or flash new code via USB, basically because USB uses this same serial port. So the problem is, if your GPS is turned on and you're trying to upload new code to the board, that usually won't work. So the one drawback of this build is you actually have to physically disconnect this wire or power down the GPS when you want to actually upload code to the board. Then once you have new code flashed, you can go ahead and replug the GPS back in and hopefully you're off and running. But besides that, and besides the modification that I made to the temperature sensors to use my temperature sensors instead of these LM60 temperature sensors, I pretty much followed this exactly, and it was pretty mindless. Let's talk a little bit about the antenna since we're talking about diagrams. The tutorial also has a great setup and plans for the antenna, and you can see it's pretty simple, and I actually talk a little bit about that in this separate video where I talked about how we actually built and tuned this specific antenna build using a nano VNA. So they give recommended dimensions and lengths of the antenna ground planes, as you can see here, as well as the antenna main element. And theoretically, this should get you near the appropriate frequency for the transmit, which again was 144.39 megahertz. But as you can probably imagine, given what type of wire you're using, given the length that you're connecting, this antenna might not be resonant if you use these exact dimensions. So you may have to chop these down or tune them a little bit. And that's what I talk about in this separate video here, where we talk about how to actually tune that antenna. Okay, let's see, what else? Moving on. Okay, so with all this in place, assuming everything's hooked up and powered on and flashed correctly and working, let's talk a little bit about just the general architecture and communication scheme. So we should have this Arduino with the HX1 APRS transmitter all ready to go and basically broadcasting packets. Now the question is, where are these packets going to go? Well, we're going to have a ground station which consists of a laptop and a ham radio, which is set up to listen to that 144.39 megahertz frequency to hear those Arduino packets. Now, again, shameless plug, I have a separate video talking about how to set up the software on the ground station and how to get it to interface with the radio so that we're able to hear these packets locally on your own radio and your own laptop. So that's this video over here where I talk about how to use a program called Direwolf, which is going to allow you to listen for and decode and interpret all of these APRS packets on your local machine. Okay. Now, the goal of that is once we hear the packet from the tracking system, we can then forward that information off to, like, the internet, right? And the beauty of having this information now out on the internet is that other users, like my family or friends, can also hear these packets and track the position of my Arduino transmitter system on their phone, on their desktop, or basically anywhere in the world, right? So again, I talk about this process of how to get the information off of your ground station and onto the internet and then out into the hands of other users using a piece of software called Pinpoint APRS. And again, we have another dedicated video on the channel talking about that step in the process. Feel free to check that out if you're so interested. While we've got this diagram up, the last thing that we should maybe mention is what's really great about this system is, if you think about it long enough, our Arduino with the HX1 APRS transmitter system is really just broadcasting these packets. There's nothing to say that we're the only ones that are going to hear these packets. Other people or other listeners and receivers in the area, or even not in the immediate area, might be able to hear these packets from quite a few distance away, and they also have the ability to forward that information off to the internet so that other downstream users can get this. So again, this is a pretty nice, robust architecture whereby we are going to broadcast our position and temperature sensor information from our transmitter out to the world, and anyone who's set up to listen on this 144.39 megahertz frequency and is able to decode these packets can obtain the information and then hopefully be a little bit helpful and send that off to the internet so other people can obtain this as well. So that's the overall game plan with the hardware and the ideas and the infrastructure and the communication topology. Let's talk a little bit about getting software onto the Arduino so that it can actually interface with the GPS, the transmitter, the temperature sensors, all that kind of stuff. We got to get some software running on that Arduino board. Alright, so in terms of software, what I'm trying to use this system for is we actually want to install it on a high altitude weather balloon, and then we are going to use it to broadcast the weather balloon's position and hopefully track it as the balloon is ascending through the atmosphere. So it turns out this is a pretty popular application. In fact, there's an entire GitHub repo called Trackuino, which allows you to turn your Arduino into this tracking system. So what I did was I basically forked off of the Trackuino repo, made my own to contain some of these small modifications for things like the temperature sensor. So again, I'll leave a link to my GitHub page for this, so you can feel free to clone this down if you want to use it, or you can still reach the original Trackuino site from my page as well, and you can, if you want to do it exactly like it's done in the SparkFun tutorial, feel free to use the original version of Trackuino, which should hopefully work right out of the box. But again, mine is pretty much forked off of it with some minor changes, and in fact I can show you some of those changes. There really aren't a lot. So my version looks very similar to the original Trackuino site and repository, and you can see it basically has a lot of the software already written to do things like interfacing with the radio, parse the GPS messages, talk to the temperature sensors, and activate the buzzer and all that kind of stuff, all while broadcasting this in a nice, easily configurable situation. So again, let me just I'll show you a comparison of the original ones and my versions, and you can see I only made changes to 3 files. In fact, we can go through these one by one just so you can see. So in APRS.cpp, you can see that the only thing that I really changed here is I changed the temperature sensor. So like we said earlier, they were using these LM60 sensors. So I just commented out that chunk, and I am now using my DS18B20 temperature sensors. And again, this code, I explained this in the other video, but again, you can find a lot of different tutorials talking about how to interface with these sensors. So that's all I did right here, was basically just interface with a different set of sensors. The only other place that I made a change here was within config.h, and config.h is pretty simple. Let me start at the top of this file. All you're doing here in this file is basically configuring it for your particular application. So in particular, you're going to put in your own call sign. So I put in my call sign right there. And then I also just, this is an optional little APRS comment that you can have included in the APRS messages and packets that go out during each broadcast. So I just changed it to something else. And then also you can change the period at which you make a broadcast. So by default, it broadcasts its position every 60 seconds. I wanted to up that rate a little bit, so I did it every 15 seconds we get a packet coming out of this system. And then beyond that, I think I made one other type of change, basically the type of buzzer. Depending on if you have an active or a passive buzzer, you may need to change this or not. So yeah, that was the very small changes in config.h, and then I think I only had one more change here. Yeah, okay, in the main Arduino INO file, I think I made a few changes here. Yeah, again, this here is to basically get my new temperature sensors, which use this one-wire bus to talk to it. So basically, that's all I'm setting up here, is setting up my new temperature sensors. And then, again, new temperature here, just from a different source. And that's pretty much it. Everything else is pretty much the same. So again, this is surprisingly easy to do right out of the box. It really is a matter of just getting the Trackuino GitHub page, forking it for your own purposes, making whatever small changes you need to make your system work, and pretty much flash this up to your Arduino, and you should be ready to go almost right out of the box. I mean, I admit it did take a little bit of debugging to get some of this stuff working, but it really wasn't too painful. This really is a really nice project where it allows you to create this Arduino APRS tracker very easily. So, with that being said, I think now we've talked about basically the circuit diagram, the components, the architecture, and now the software. So, you know what? All we need to do is just build this thing. So, let's go and do that, and I'll show you the final result. All right, and here's the physical build of the system. I guess I'll be the first to admit that it's maybe not the most clean and professional, but I basically housed everything inside this little DIY 3D printed case. I'll leave a link in the video description to this case in case you want to download it and print it yourself. But as you can see, it basically houses the Arduino, the HX1 radio, the GPS, all that stuff, as well as it has external wires to go to the GPS antenna, R2 temperature sensors, a power for powering the Arduino via our 2S LiPo battery, and then we also have the buzzer out here, and then finally the SMA hookup to get the HX1 radio hooked up to our little DIY antenna. If you're interested in this antenna and how to tune it, I actually have a separate video on that. Again, I've got a link in the description for that video, but long story short, here is the overall pretty much finished hardware. So let's see if we can get this installed, and actually we're going to install it in this little styrofoam payload box. This is actually a payload box that we're trying to install on a high altitude weather balloon to use the HX1 to track the position of the payload as it's floating through the atmosphere. So let's get all of this packaged up and installed inside the payload box and hooked up to the antenna, and then I think we're ready to go out and get some data sets. All right, so here we are out at the local park, and we've got the APRS slash HX1 radio system all installed into this little payload box. So again, this is our payload box that we are going to be sending up into the upper atmosphere, hopefully with our high altitude weather balloon, but we can use it for testing just to make sure that the APRS transmission system is working correctly. And again, you can kind of see I've got our two Baofeng radios out here. So again, in our previous video, we discussed the setup of how to basically get the packets coming off of the HX1 radio being sent out. So the APRS packets are being sent out wirelessly using obviously the antenna system that we've got here. It's being then picked up by actually both of these radios. So this radio here is just going to broadcast it. So you'll hear it squawking every 15 seconds when it receives a packet. Let's see. Yep, there you go, there's a packet. And then this radio is actually hooked up to the computer via a cable. And then what this computer is doing is the computer is running Direwolf. I don't know if you can see that very easily. It's probably really hard to see with the sun and the glare, but it's decoding these packets. So again, we talked about this entire setup and how to get everything working in a previous video, so I won't go over it in major detail, but as you can see, it's working right now. So what we should do is let's walk the payload box around the park just to make sure this is working and make sure that we can still receive packets here back at the base station. All right, so as you can see, here it is. Here's the log file that our ground station collected after listening for all of the APRS packets. So if you open this up, you can see it's got a ton of data, and most of it looks to be messages and packets with our call sign, and it has all of our information. So here's our location as we're walking around, along with other information, and even over here in the comment part of this message, so you can see the last entry is the comment. You see that what we've done using the Trackuino system is embed the temperature sensor information into the comment. So if we just write a little bit of code to go through this entire file, and we should just basically sort on our call sign and then parse the position information here and parse the temperature information that is in the comment, we should be able to basically visualize this entire data set. Again, what's interesting about this is you can see there's more than just our packets. For example, right here, you can see this is somebody else's call sign. They're broadcasting other information out on this channel, and we're able to pick up these packets and decode them. So again, all we got to do is write a little bit of code to look at just our information, and in fact, that's what I've done over here. I wrote a quick little MATLAB script to do a lot of this analysis, so let me just run this, and we can see what ended up happening. So looks like we have about a 47-minute long data set. as we were walking around the park, and here it is plotted up. So if you look at this, let me zoom out a little so you can see. This looks perfect. See, we were here on the south end of the park, and it looks like we started over here. Yeah, this is exactly correct. I think this is where we turned it on, and we just started walking around in this circle, going around, and then we stopped. So we've got the position information collected very nicely, and then we also have additional information, like we can get speed of the object by just doing, you know, kind of finite differencing on the position. But what's more interesting is we also have, yeah, like we said, altitude, and then the two temperature sensors right here are being read and parsed out of that comment section. So you can see that the first sensor, I think this was the interior temperature sensor. You can see it started out here, and then I think what ended up happening was we took it out of the car. It was in the car, and it was kind of warm, and then we took it outside, and we were getting all set up, and as you can see, the temperature is dropping because it's cooler outside, and then we were walking around the park, and then I think we put it back inside the car, and you can see the temperature start coming back up higher and higher. And same thing with this other sensor. So I think this is maybe the exterior temperature sensor, would be my guess. But anyway, this is pretty great. Yeah, the other thing that maybe we should mention is we're also able to kind of measure what we anticipate is the battery voltage to see the state of charge of the battery given this system. So we can see if we're getting low or not on batteries. Let me do you one better. Then instead of just walking around in this park, now that we validated this worked, what we actually ended up doing was we used this on our high altitude weather balloon, and we actually were able to launch with it. So I'll show you a quick video. This is a little video excerpt of the launch, and you can see we've got the system inside, and we basically let this balloon go, and it flew over eastern Washington a very far distance. I think it went actually over 81,000 feet in altitude, and we were using this tracking system to gather data and listen to it as it flew along in its course. So tell you what, let me show you that right now. Let me just switch the data set. So let's go load up the data for our weather balloon launch. And for giggles, I just wanted to show it to you. I have a much more in-depth discussion of the results of this launch on our actual video for the weather balloon. So again, here's a link to the video. You can kind of see it popping up in the upper portion of your screen. So if you go there, if you want to see an actual discussion of this data and an analysis, feel free to go over to that. But as you can see, look at this. This is looking great. We launched down here next to the river, and the balloon floated many miles. Look at the scale. I mean, this is probably, it traveled, I think, 30 miles laterally, or maybe even more. And if we look at the altitude profile, what's fascinating about this is it went to, I believe, around over 80,000 feet. I can't exactly remember. Well, yeah, we did lose data. So you can see these flat sections are where we actually didn't hear any packets. So MATLAB is just connecting the dots. So unfortunately, there's a data point here that we lost connection, and the next data point it picked up here, and then it continued gathering data. We were hearing it down at the ground station. And again, we lost communication here when it went super high, but we actually were carrying a secondary data logging system on board that would allow us to capture data even if we weren't communicating. So again, I would refer you over to our weather balloon launch video if you want to see a complete discussion on the data and all of the systems that we had running. But as you can see, this system was working quite well. We were able to track it pretty darn nicely, and you can see the temperature sensors were both responding. So this again was the live information that we were getting back as the balloon was flying up, and we could see where it was going. Let me show you one thing. You can actually see the gaps in the data if I just change one bit of the plotting script. Let me change this from, instead of a trajectory, let me just plot a scatter plot to show the actual location of the data points. And I think you'll be able to see that a little bit more easily about where we lost information. Aha, here you can kind of see. So when we launched, we kept the ground station down here at our launch location, and we were just watching the balloon float along, and all this time we were hearing all of these APRS packets. We were getting them. Everything was hunky-dory. But then out here, I think it got far enough away from our ground station that we were not able to pick up those packets. That's why we lose data in this area. Now, the reason we get it back was kind of a couple of reasons why we got this data back. One reason is we actually packed up our base camp and we started driving to try to chase the balloon. So at some point we reestablished contact with the balloon as we were driving along. So you can see we got a couple of blips here, and then we lost contact again, and then we got a few more blips here as the balloon was actually, I think this was when it was actually descending and coming down. We were able to track it. So again, all in all, this system seemed to work great, even in this extreme case of having a weather balloon where it was flying at over 80,000 feet and many, many miles away. So again, we were thrilled with how well this system worked. All right, so there you have it. A pretty reasonably cheap and easy way to build yourself a DIY APRS based tracker using this GPS module and the HX1 radio. So as you can see from our payload from our high altitude weather balloon, this is actually our recovered payload after we did our launch, and we've got the unit sitting inside there. And again, you can see the antenna got a little bit banged up, but it definitely functioned. So this was a lot of fun. It was a nice project, and it was successful even in these circumstances and harsh environments like a high altitude weather balloon launch. The last thing that maybe we should talk about is some of the costs and the parts associated with it. So I'll just flash a screenshot up here showing some of the major components and how much they cost. And as you can see, it was a pretty reasonable in terms of financial investment. Really, you can see the radio was by far the most expensive thing. At about half of the price of the project was just buying that single radio. Otherwise, it's just pretty much using a standard full-size Arduino and then associated components to get it connected to the GPS module and route it out to the antenna. So again, I'll leave a link to these, a more full, complete description of the parts list in case you're interested in recreating it on your own. Just feel free to look for that in the description of this video. So, with that being said, I think this is probably a great spot to leave it. I hope you enjoyed the video, and if so, I also hope you'll consider subscribing to the channel. Surprisingly, if you just scroll a little ways down and actually click on that subscribe button, it really helps me continue making these videos. And we're going to have a lot more videos discussing ham radio, high altitude weather balloons, and in general just science projects for kids and things like that in the future. So I hope we'll be able to catch you on one of these future discussions and we can all learn something new together. So until then, I think I'll sign off. Talk to you later. Bye.